Alright folks, here in this video we are going to close up our discussion of surface area and volume of different solids. And specifically in this first video of this unit we are going to look at the surface area of a sphere. Surface area of a sphere. So let's think about this here for a sec. Okay? So when we think about a sphere, right, a sphere, just simply put, is the set of all points in space equidistant from a given point. I say that's simply put, but I guess it's not really simply put necessarily, right? What we just want to think of it is if this is our center point, right, any single spot that I went to in 3 dimensions is equidistant to that center point, right? It's just a bunch of different radii that I could connect: forward, backward, left, right, up, down, all the above. Now we have a familiar term, chord. The chord of a sphere is just simply a segment whose endpoints are on a sphere, and the diameter of a sphere is just one of those chords. It still is a chord, right? That contains the center of said sphere. Now, what we end up having here is that if you were to take a cross section of a sphere, or cross sections is when you split a solid, what is the two-dimensional shape that actually is created by that cross section? Well, obviously it would be a circle when you slice up a sphere. But if you do it in such a way where you slice through the center of the sphere, you create 2 hemispheres, just like it is in our Earth. We have 2 hemispheres, right? And what ends up happening is that the cross section, if it includes the center, that one circle right in there ends up being called the great circle. Ends up being the great circle. Now we're going to spend a whole lot of time necessarily utilizing that, but it can help us definitely in different situations. So let's talk now about the surface area of a sphere. Now, I got a baseball on here for you guys because I think it's the easiest way to think about it. So if you play baseball or softball, or if you have any idea of what a baseball or softball looks like, it is a bunch of leather that has got some kind of twine and cork inside, right? That is all stitched together by these red laces. And if you can imagine undoing all of those laces, you create a figure that is just like you see unraveled right here. And what ends up happening is that you really end up creating 4 different circles. 4 different circles. So that means the surface area of a sphere is 4 times the area of a circle. 4 times the area of a circle. So I hope that was kind of cool to see the breakdown of how a baseball can be represented in the surface area of a. So let's take a look at an example, or a couple examples of how we can put this into some application. So the surface area of a sphere is 4 pi r squared. So in this case, pretty basic, 4 times pi, the radius clearly is 8, so 8 squared. So the surface area here would end up being 4 pi times 64, which equals 64 times 4. And since pi really is exact, I really like keeping it in pi unless it tells us otherwise. So we can just leave it as 256 pi, and of course we're back to area, so we are inches squared. What about for part B? It says that the circumference of the great circle, is 12 pi. How interesting, how interesting, how interesting. Well, why is this important? Because remember, the circumference is 2 pi r. So if that's the case, if 2 pi r is the circumference, 12 pi is the circumference of the great circle, that means that the radius would have had to have been 6. The radius was 6. This is a fascinating problem of how we can show the great circle in application using the circumference to then find the surface area of 4 pi, now radius 6 squared. 4 pi times 6 squared. So we end up getting 6 times 6 is 36, times 4, 144 pi feet squared.